So welcome again to the Functional Skills Bite-Size session for ratio and scale. Few objectives for this session. So by the end of the session, you should be able to recap the basics of ratio in its simplest form, identify ratio used in scale examples, and successfully calculate the size of an object using scale. So quite a short session. It will be interactive, so I'll get you guys to do some activities, and we'll be able to establish then if you get the answers right, then you've obviously improved, and if you don't, then you'll need to do a little bit of work on it. So let's have a little look then. Apologies, I'm going to look off the screen because my eyesight seems to be very, very bad and I can't see the small writing today. So I'm going to look at the bigger writing. So we're just going to have a recap on ratio. So what is ratio? I've already mentioned what you're looking at on the screen now, and I recommend that you watch the probability and ratio bite-size session that we carried out previously. Before I tell you what ratio is, anyone like to provide an answer? Was that too soon? Too soon? Okay. Let's have a little look then, see what ratio is. So ratio is a relationship between two or more values, and it's usually presented like this. So you'll have amount of one thing, a colon, so your two dots, and then amount of another, and it will usually look like A colon B. And got a nice little image so you guys can see. So you're comparing one value to another. It's quite thinking about it. It's quite tricky to ask you guys to say what that is, isn't it? Really, a bit through in the deep end. So we're going to have a little recap on ratio in its simplest form. So I've just got a question here. So more often than not, you will find ratio, and it's usually presented in its simplest form. In its simplest form basically means in the lowest form that you can get. But that usually relates to a bigger number. So for this example, we've got share £20 between two people in the ratio of 3 to 1. So we've got 3 to 1, A to B. Before I go through how you do this, anybody like to tell me what the answer is? Anyone think they know what the answer could be? What the answer is? Fab. I said fab and took a sip of my drink then. Fab, so 15, the person A would have £15 and person B would have £5. This example is quite simple, and a lot of people can see how you would what the answer is without knowing how you would get there. So even though we know what the answer is, do you know how we got that answer? Anyone? Nobody's answered yes, so I'm going to take that as a no then, which is excellent. So I can explain how you get that answer. So first thing that you would do, this is a nice simple example, like I said, but in questions they're not always as simple as this. So the first thing that you would do is find out how much one part is worth first. So to do that, you would look at, let me just get my pointer, sorry. Oh, that. So you would look at the ratio, and so we've got the part A has 3 parts and part B is 1 part. So you would look at that and you would add those two together. So you would add 3 and 1, which would give us 4. And then to find out how much 1 part is worth, we would then into my slides. There you go, I'll use the visible, talk to myself. I'll use the visible arrow so you can all see my arrow. Okay, so then what you would need to do then, now that we know how much 1 part is worth the value of the one part, we can now divide 20 by 4, and that would tell us how much one part is worth. So if you divide 20 by 4, it would tell us that one part is equal to £5. So now that we know that, we can work out how much, I'm going to call it person A, is going to get compared to person B. So then we would, person A, we would multiply 3 by 5, which would give us 15, and person B would just be multiplied by 1. So they would just get, poor person B, they would have 1 times £5, which would be 5. And that's how you would share out the value of £20. And it can be, no matter what the ratio is, you use the same process to do that. Just curious, Louise, did you did you know how to do that when you provided the right answer? Lovely, awesome. You can apply that to anything, as long as you know the basics. You can apply it to the harder questions. I don't know if somebody just pop your sound on mute for me, please. That's lovely, thank you. Okay, so moving on from ratio, I did say it would be a quick recap. Again, I feel like I'm advertising this ratio bite-size session. Again, I would recommend visiting that that session and having a watch over it. It goes into more detail about ratio. Before we go on to looking at ratio as part of a scale, a few important bits of information for a non-calculator paper. Obviously, with your maths paper, sorry, are split into 2 different sections. So one section you can use a calculator for, and the other one you can't. So when you're doing the non-calculator paper, make sure you show all of your calculations. It's really important. Even if you know how to do the calculation in your head, you won't be awarded the mark unless you show how you've worked it out. So it could be that the question is worth 2 marks, and just because you put the answer there, you will only get 1 mark because you didn't show your workings out. So the reason behind that is that you're demonstrating your understanding of the question in your answer, and how you have come to the conclusion. So the reason why in the last slide I showed you the process of how you actually found out that it was 15 to 5 is because if you just wrote the answer 15 to 5, you would only get 1 mark. You need to show your workings out as well of how you got to that answer. And not everyone knows how to do that. Just a little tip there. So again, I think I just mentioned this. So look at the marks awarded. If there's more than 1 mark available, then you will definitely need to ensure you include everything possible in your answer. So it could be that, say there's 3 marks. It could be that 1 mark would be for the answer, 1 mark would be for the workings out, and then the other one would be for the quantity. So it could be that you need to make it clear that it's centimetres and not metres. It's another thing to think about. Okay, so we're just going to move on to looking at scale drawings now, and how ratios are used in these examples. So quite often ratio is used on maps, drawings or plans to provide the size of an object or distance. So you can see a looking scale as 1 and then your colon and then to 20. So 1 to 20. So we're going to have a little look at some examples in a moment. Anybody know how we will work out the actual size of the object from the scale before we look at it? Again, that's a bold question. Nobody want to answer? That's absolutely fine. Okey-doke. Got a little tip when we start looking at a scale in a second. So if you're increasing the size from the scale, you'll be multiplying, and if you were decreasing the size, you will be dividing. And that's something that will be made clear as we go through the examples now. Okay, so let's have a little look at some examples. So I've got 4 examples in total. The first one I will go through with you and show you how to do it, and then the second one you guys will do that by yourself, and then I will talk you through it. So 2 examples are, first 2 are for increasing the size, and the second 2 are for decreasing the size. So I'm just going to get my highlighter ready a second. So those of you who joined my session on Tuesday, you know that I like to use the highlighter. It's not just because I like highlighting, it's because it's a really useful tip when you're actually doing the exam, and it's really good to highlight the main points. So I would recommend highlighting the main points so they stand out to you, so you can see exactly what you're going to be doing in the question. So we've got a model car has a length of 12 centimetres. Oh, we've got an answer already, 48 centimetres. We shall see. Okay, so model car has a length of 12 centimetres. The scale of the model is 1 to 40. Find the real length of the car. So this information, 1 to 40, it means that for every 1 centimetre of the model car, this is equal to 40 centimetres in real life. So the dimensions of the car is 40 times bigger than the model version. So I don't need my, I am good. So the information that we need. So we know that the model car is 12 centimetres in length. Highlighted. My eyesight's really bad today. It is highlighted. So we know there's 12 centimetres in length. So we know that 1 is 12 centimetres. And we want to find the real length of the car. So we need to find out what the 40 is. What the real life version is then. So we know the model version is 12 centimetres, and we might have some right answers in the chat. We'll see now. And we want to get the real life version. Okay, so let me get my pen out. So what are we going to do? So we know that, so we've got 1 to 40. We know that 1 is 12. And how do we find out what 40 is? Anybody have any ideas? What are we going to do to find out the size of the real life car? 40 times 12, absolutely. Now, some of you may have noticed that I've got a funny looking box on my screen. Now, when I do a multiplication, I don't like to do the traditional method. I like to use the lattice method to do my multiplying. So I like to use this little box method, which I can't write properly on this screen. So forgive me, please, for my writing skills. However, you would multiply 12 by 40. And the answer, you want to see if I can work this out now, don't you? So obviously I can. Just out of interest, anybody seen this lattice method before being used? No? Yeah, some of you have. So some of you who've seen it before, you might, if you've seen it before, you either like it or you don't like it. I really like it, so it is the method that I use. If you haven't seen it before, you might want to have a little look at the video that we've got to show you how to actually work out the lattice method. So I'm going to do the lattice method here just to give you guys an example of how you do it. But basically, use the boxes to multiply. So I'm going to multiply 4 by 12. So I'm going to start with 2 first. So 4 by 2 gives me 8, so put a 0 there and an 8 there. Oh, 4 times 1 is 4, so I'm putting a 0 here and a 4 here. Let's excuse my writing. And then 0 times multiplied by a number is 0. So that's nice and easy. So I'm not even going to bother with my struggling to write my zeros. I'm just going to put a dot. So now I'm going to add up then. So I've got a 0. I've got 8 there. I got 4 there, and I've got a 0 there. Now this is where I find this version helps. Now I noticed in some of the answers, some of you put 48 earlier, but you'll notice is we would knock that off. So we've got 480, so 480, and maybe multiplying the traditional method. That's maybe how you got 48 to start with. This way I find we don't tend to forget about the zeros. If you're interested in the lattice method, then I would recommend watching that video. If not, you can absolutely stick to your traditional method. So that's how you get 480. So it would be the length of the car would be 480 centimeters. Or if you wanted to put it into meters, of course, it would be 4.8 meters. 4.8 meters. Yeah, everyone agree with that? Oh. Yeah, no? Okay, so yeah, oh, thank you very much. So if you guys try this scale version now, so we've got a model of a building as a height of 40 centimeters. The scale of the model is 1 to 500. Find the real height of the building. So I'll give you a minute or two to work this out. A few answers coming in. Fab, yes, so we've got right answers coming through, lovely. So 200 meters, absolutely. Everyone okay with the process of how you would work that out? So you would, what have we got? Let's get my highlighter. Oh, I'll just underline it with my pen actually. So we've got a height of 40 centimeters and we've got a scale of 1 to 500. So you would multiply 500 by 40. Yep. And then you could either have the answer, it doesn't specify what the answer is going to be. So it would either be 20,000 centimeters or 200 meters. Okay, you all right with that one? Yeah. Perfect. Okay, so I'm going to have a little look at our second example now. Ish. I like that. That's good. We can work on that. We can work on ish. Okay, so looking at our second example now, this is decreasing the scale. So I mentioned earlier, I gave a little tip. So if we were increasing, we'll be multiplying, and if we're decreasing, we'll be dividing. So for this one then, we've got a scale drawing of a doll's house as a ratio of 1 to 25. That's a very lovely doll's house in that picture, isn't it? The real height of the doll's house is 2 meters. So find the height of the doll's house on the drawing and give your answers in centimeters. I was going to talk you through this one first, but since you guys were so quick with the other example, I'm going to see what answer you come up with first. Somebody's put an answer there already. Awesome. Perfect. I didn't even need to talk you guys through it. I will talk you guys through it though, just in case some of you don't know how you would have done it. So let's have a little look then. So meters 1 to 25. The height of the doll's house is 2 meters. Find the height of the doll's house in the drawing. Okie doke. So basically, all we're going to do is what we're going to do first, though. I've asked, you've been asked to find the answers in centimeters, and the height of the doll's house is in meters. So what you would do is make sure that your measurements match. So the first thing that we would do is we would turn 2 meters into centimeters, and to do that we would multiply it by 100. So you would have 200 centimeters. My writing's terrible on you. So you'd have 200 centimeters in place of 2 meters, and then what you would do is divide the 200 centimeters by 25. So you would divide that by 25. I'm not going to waste time working this out. So you divide that by 25 by the time I write it out. The answer to, so 200 divided by 25 would be 8 centimeters. Are we all okay with that answer? And working's out. Yeah. My lady who was an ish, Lynn, was it? Was it Lynn? Are you all right with that answer? That way seems easier. Yeah, it probably, I think either a multiplier or a divider, I think, and if it's easier dividing, then it probably would be easier, yeah. So you'll probably find the next question a little bit easier then, but I agree, practice definitely if this isn't your strong point. So next question then, so try this one then, everyone. So we got, this one's a map, so we got a map has a scale of 1 to 50,000. The real distance between the two towns is 15 kilometers. Find the distance on the map between the two towns and give your answers in centimeters. Now, there's a lot of zeros in this one. I'll give you a bit of a heads up. But if you guys have a go at doing this one. Any answers yet? Anyone got an answer, but you're not sure if it's the right answer, so you don't want to put it on the chat? We got an answer. 30, fab. 30 lovely centimeters. Fab. A little bit more complicated, this one. So I will talk through this one with you guys. So the first thing that you need to do is, so we've got 15 kilometers and we want our answer again in centimeters. So we're going to convert 15 kilometers into centimeters. The easiest way to do this, so if I were doing it, I would change it into meters first and then change the meters into kilometers. So changing 15 not kilometers, sorry, centimeters, just to confuse you guys, say the wrong thing. So 15 kilometers in meters would be, so I know that I will be adding 2 zeros. That's the easiest way that I do it. So that would be in meters. And then if I were to turn 1500 meters in centimeters, sorry, it's just is it me or that I would have an extra 0 on there, wouldn't I? If it was anyone back me up on that, 15,000. Thank you. That's where I was getting myself confused. I was thinking, I'm sure there should be another 0. So it would be 15,000 meters. Thank you. You could all see my confused face then, couldn't you? It was like, that's not right. So then I would change it into centimeters and then I would add the 2 zeros. This is where I got my 2 zeros on. So if I was going to change it to centimeters, so we would have lots and lots of zeros. To be precise, we'd have 5. Yep. Anyone want to check me that I'm right on that, just in case I made a mistake? Oh. Yes, perfect, lovely. Okay, so now we've got our zeros right, and we've got our centimeters. So we've changed it from kilometers to centimeters. Next thing that we're going to do is we're going to divide 1,550. Oh, there's too many zeros for me. I'm going to divide that number by 50,000. That's the next thing that we're going to do. And I am not going to write all of them. It might be a long time. All right, and then 50,000. Basically, if I was going to put it down there, if I was going to work this out, I would knock the zeros off first. That's how I would do it. So I would go and take 2 zeros off first. We take 2 zeros off there. That's how I would do it. And then what have we got left? 50. How many times does, oh no, I've taken an extra, I've taken an extra one off. Oh. Someone back me up there. Anyone? And then 50 divided by 5. The answer to that. 500, isn't it? 50 divided by 500 divided by 50. Paul's going to back me up now. I can see. What we got, Paul?
I think that looks good to me. I'm just checking some numbers here, and I think so. If anyone's got a calculator, try it on there as well.
Yeah.
There's always the cheating way of doing it.
No, I think it's right, isn't it? 50 divided by 5, so that would be, what have we got? 50 divided by 5.
I think you've missed the 1 off the beginning. Be 15 there somewhere.
Do you know what? Thank you. How many people in the session? Only Sophie spotted that. There's your test.
Well done, Sophie. Well done.
Thank you. Now I can see why I've got myself awfully confused. And the person who got the right answer as well didn't spot it either. So 0 marks for well done, Lynn. You spotted it and you were still on ish. So well done. Awesome. Passed the test. Anybody like to explain how you get the right answer? So obviously I didn't do a very good job of that. Anyone? Anyone? No one? Okay, so let's get the right figures then, is there? So if we've got 15, 15, absolutely 150 divided by 5. Yeah? Or 50,000. Now that we've got the right figures, I would knock off the zeros. 1, 2, 3. Oh my gosh, a zero. Oh. Okay, I think we've established the answer is 30. So the answer is 30 centimeters. Yeah?
Yeah, that's right. So then 5's into 150.
Yeah?
Yeah.
Fab, awesome. Lovely. So hopefully then in your test you won't have a figure with lots of zeros. Few top tips. So ensure that you highlight the information that is important. Obviously, I think where I went wrong is I did not highlight the information when I was talking through the example. Properly confused myself. Second one is to convert. So if the measurements are different, make sure you convert them correctly. It's best to do this before you do any ratio calculation. Identify if you're increasing or decreasing the object, as this will determine if you're multiplying or dividing, and show your calculations. So if there are 3 marks being awarded, providing the answer alone will not meet the marking criteria. Even as an example then, highlighting is key, so I clearly didn't do that, so I made a mistake. However, I did show all my workings out, and if the process was there, I probably wouldn't have had full marks, but I would have had a mark for the process as well. So you don't necessarily get the answer, a mark for the right answer. You need to show your processes. So hopefully by the end of our session, we had a quick recap on the basics of ratio in the simplest form. We identified ratio used in scale examples, and you successfully calculated the size of an object using scale. You did, I didn't, however, but well done everybody else. So that concludes our bite-sized session on ratio and scale.